Welcome to the deep dive. I am so glad you could join us today because we are getting into a scenario that honestly feels like a high-stakes thriller.
It really does.
Even though the entire plot unfolds entirely inside an engine block,
Right.
I want you to picture your typical day running a massive multi-million-dollar operation. Maybe you were overseeing a sprawling mining site or, managing a critical utility grid.
Or directing a remote oil rig out in the middle of nowhere.
Exactly. And everything is humming along beautifully. Your crews are working, the schedules are perfectly synchronized, the margins are holding steady. And then suddenly everything just comes to a grinding, catastrophic halt.
Just out of nowhere.
Right, the whole operation shuts down. And the culprit isn't a hurricane, it isn't a massive structural failure, it is a single microscopic enemy that somehow managed to slip past your multi-million-dollar defenses.
Yeah, I mean, it is the exact scenario that keeps operations directors awake at night. You have a tiny, almost invisible vulnerability bringing down an absolute titan of industry, completely unannounced.
Okay, let's unpack this, because today we are looking at the mechanical, the financial, and the strategic layers of what it actually takes to keep the heavy machinery of the modern world running. We've got an engineering and procurement briefing here.
A really detailed one, too.
Yeah, it's titled Caterpillar 423-8521, Engineering Reliability and Procurement Strategies. And our mission today is to explore how one seemingly unglamorous, easily overlooked component is basically the only thing standing between industrial harmony and absolute chaos.
It is. This really is a masterclass in risk management and procurement strategy.
Right.
It's an exploration of how the smallest, most granular details dictate the biggest, most expensive outcomes in heavy industry. We are looking at the reality that reliability isn't an accident, and it certainly isn't just good luck.
Definitely not.
It is a highly engineered reality that requires a very specific operational posture.
So let's meet the villain of our story. We are talking about water in diesel fuel. The briefing refers to it as a silent assassin, which is just incredibly ominous.
Very fitting, though.
It's lurking right there in the fuel tank, completely undetectable from the outside, just waiting to strike. But I want to understand the actual mechanics here. Why is water so deeply catastrophic to these engines? What is it actually doing inside that system?
Well, what's fascinating here is the precise physics of the damage this silent assassin causes. Because it isn't just a minor nuisance that makes an engine sputter for a few seconds. Modern diesel fuel systems operate at insanely high pressures.
How high are we talking?
We're talking tens of thousands of pounds per square inch. At those pressures, the diesel fuel itself is actually acting as a vital lubricant for the incredibly precise internal moving parts of the fuel injectors and the high-pressure pumps.
Right, diesel is essentially an oil.
Exactly. But water has zero lubricity. So when microscopic droplets of water get introduced into that high-pressure environment, they wash away that protective lubricating film.
Which sounds bad enough on its own.
Oh, but it gets worse. Under those extreme pressures and temperatures, water can rapidly vaporize and implode. It's a process known as cavitation. These tiny, violent implosions literally pit and erode the hardened steel of the injectors.
Wait, so it's essentially blasting the inside of the engine apart on a microscopic level?
It is acting exactly like liquid sandpaper inside precision fuel systems. It corrodes those precision injectors, fouls the high-pressure pumps, and clogs the advanced filtration media.
Wow.
The downstream effect is immediate and devastating. You go from having a perfectly healthy, incredibly powerful piece of equipment to owning an incredibly expensive paperweight literally overnight.
Put yourself in the shoes of the crew on the ground for a second. Imagine the sheer, visceral panic of that moment. You are in a remote location, maybe hundreds of miles from the nearest service center.
Yeah.
You are depending on this piece of heavy equipment for your safety, your power, your livelihood, and suddenly, nothing. Silence.
Just terrifying.
A highly technical mechanical issue instantly becomes a massive human problem. People are stranded, production schedules are entirely blown up, and the clock starts ticking on massive financial losses.
And that reality dictates the engineering response. You cannot afford a passive defense against that kind of threat.
Which brings us to the countermeasure, the unsung hero. The Caterpillar 423-8521 fuel water separator.
There it is.
And this isn't a glamorous piece of technology. It is not going to win any industrial design awards for its aesthetic. There's a great sentiment in the source text about parts like this. When it's doing its job, you don't call me. When it fails, you do.
That sums it up perfectly.
It operates entirely in the background, but its success determines the fate of the entire machine. What makes this specific separator so effective?
It comes down to a design standard Caterpillar calls advanced efficiency. And this isn't just a marketing label, it is a rigid, measurable performance metric. The 423-8521 is engineered to remove virtually 100% of all free water from the fuel system.
100.
Yes. That means every single free-floating water droplet is trapped before it can advance.
Okay, but what about the water that isn't free-floating?
Right, that is the emulsified water. The moisture that has essentially been blended and homogenized directly into the diesel itself, which is incredibly difficult to extract. This unit removes about 90% of that emulsified water.
That's a huge reduction.
It is.
Yeah.
And simultaneously, it is stripping out the fine microscopic particulate contaminants that contribute to that sandpaper effect we discussed earlier. It is a comprehensive filtration barrier.
And we are not talking about small consumer-grade engines here. What scale of machinery actually relies on this specific separator?
The applications are staggering. We are talking about massive industrial-scale power plants. The documented compatibility covers the Caterpillar C13, C15, C18, C27, and C32 engines.
Those are mass.
Huge. It also covers heavy-duty power generation platforms, specifically the SR5 XQP500 generator sets.
Wow. Okay, so we're talking about the massive engines powering the largest haul trucks on Earth, the heaviest mining excavators, and the gensets that are single-handedly keeping remote hospitals and sprawling work camps lit.
Exactly.
This is the backbone equipment of global infrastructure.
It is. And when you are dealing with equipment operating at that physical scale, the financial implications of a failure scale up just as aggressively.
Here's where it gets really interesting, because fixing this isn't just an engineering problem. It immediately becomes a massive financial liability. For any procurement manager or operations director out there listening, this is where the rubber meets the road. Let's talk about the actual cost of downtime.
The return on investment for preventing these failures is brutal and instantaneous. A single hour of unexpected downtime on a C32 engine or an XQP500 genset costs exponentially more than the price of a pallet of these filters.
Right.
When water bypasses the separator, you aren't just looking at a minor repair bill. You are looking at a catastrophic five-figure event.
5 figures, just evaporating.
Easily. You are talking about replacing an entire set of precision fuel injectors. You are pulling out and rebuilding high-pressure fuel pumps. You might be dispatching a heavy-duty tow rig into a hostile environment to drag a dead generator out of a remote worksite.
Which is a logistical nightmare.
Exactly. $10,000, $20,000, $50,000 in direct costs, completely ignoring the lost revenue from the halted operation.
But the benefits of running this premium separator go beyond just avoiding a catastrophic failure, right? There's a domino effect to running genuinely clean fuel.
Absolutely. The cascading benefits of pristine fuel fundamentally optimize the everyday performance of the machine. First, you obviously see a massive reduction in routine injector failures, which lowers baseline repair bills and planned downtime.
Makes sense.
But beyond that, cleaner fuel directly translates to better combustion efficiency.
Meaning the engine doesn't have to work as hard to generate the same power.
Precisely. Better combustion efficiency lowers overall fuel consumption and significantly reduces exhaust emissions. So you are simultaneously cutting your diesel overhead and running a greener, more compliant operation.
Compliance is huge.
It is. And speaking of compliance, for heavily regulated sectors like oil and gas or municipal utilities, improved safety and regulatory compliance are paramount. A sudden engine failure on an active drilling rig isn't just a mechanical issue. It is a trigger for a massive safety incident investigation.
Nobody wants that.
No. Standardizing on high-efficiency OEM components keeps you compliant, safe, and keeps the administrative side of the business running smoothly during audits.
Okay, I have to play devil's advocate here. Because if I am a procurement director and I am staring down a mandate to cut my operating budget by 15% for the upcoming quarter, those third-party aftermarket filters look incredibly tempting.
Of course they do.
There are cross-reference tools out there, sites like inlinefilters.co.uk or fuelfilter-crossreference.com, that will happily generate a list of compatible aftermarket alternatives for a fraction of the cost of the OEM Caterpillar part. Is the OEM premium actually justified, or are we just paying for the brand name stamped on the cardboard box?
It is the most common question in industrial procurement, and it represents the ultimate false economy. Yes, those cross-reference tools are incredibly valuable, especially if OEM stock is depleted globally and you are in an emergency situation.
Right, like a stopgap.
But relying on cut-rate aftermarket parts as a primary financial strategy is incredibly dangerous.
Why? If it threads onto the same mount and filters the fuel, what is the actual risk?
Because not all filtration media is created equal, and the manufacturing tolerances are vastly different. If you gamble on an unknown cut-rate filter, you are risking catastrophic failure. The filtration paper could delaminate under high pressure, sending debris directly into the injectors.
Causing the exact problem you're trying to prevent.
Exactly. The seals could fail, introducing air into the fuel lines. A cheap filter that stales in the field costs exponentially more than the premium you saved on the purchase order. Saving $20 on a filter to lose $20,000 on a blown injector pump is a phenomenal way to destroy an operating budget.
That puts it in perspective.
If a procurement team is absolutely forced to explore aftermarket options, they must rigidly test and qualify that supplier in a controlled environment first. You never test unproven parts on mission-critical field assets.
Which perfectly transitions us into the strategic layer of all this. Because if you were operating at scale, maintaining this level of reliability isn't just about clicking add to cart on a website. Sourcing these components requires a highly sophisticated supply chain strategy.
It certainly does.
Let's put you, the listener, in the shoes of an operations director managing a massive, geographically dispersed fleet. You need these separators by the pallet. What are the actual hurdles to buying at that scale, and what should you demand from a vendor?
When you are procuring at an industrial scale, you are buying much more than just the hardware. You are buying supply chain resilience. The first non-negotiable demand is proven traceability. You must have rigorous lot numbers, verified manufacturing origins, and quality certificates.
So, paper trail.
A flawless one. If a component fails prematurely, you need the infrastructure to instantly trace exactly where it came from, what batch it belonged to, and what other machines might be at risk.
You cannot afford mystery parts entering a multi-million-dollar fleet.
Exactly. Next, you demand guaranteed compatibility for your specific asset list. Then, you negotiate bulk pricing with locked lead times. The locked lead time is crucial. You cannot schedule preventative maintenance if your delivery windows are constantly shifting.
That makes scheduling impossible.
Furthermore, a top-tier wholesale vendor has to offer advanced inventory management.
Like consignment options and kitting.
Yes. Consigned inventory keeps your balance sheet lean, and kitting is a game-changer for field efficiency.
Let's talk about solutions, because this level of logistical support is historically very difficult to secure. We are looking at PEEnergy.com as a primary example of how to solve this exact bottleneck. And it is important to note they are structured exclusively for wholesale industrial supply.
That's a key distinction.
They are servicing oil and gas, utilities, and heavy manufacturing. They are explicitly not selling single bits of hardware to garage mechanics or hobbyists.
Their entire operational model is built for scale. They provide the wholesale margins necessary to protect a procurement budget, but they combine it with fast consolidated shipping to strip out excess freight costs. And they lean heavily into that customized kitting we mentioned.
Explain the strategic value of kitting in this context. Why is it so important?
Imagine a technician in the field doing a routine swap. If parts are ordered individually, they might have the filter, but realize they are missing a specific 50-cent O-ring or a specialized gasket. That technician, who is costing the company over $100 an hour, is now standing around doing nothing, and the machine remains offline.
Over a 50-cent part.
Exactly. Kitting solves this. The vendor packages the exact filter, gaskets, and seals needed for that specific maintenance task into one single barcoded box. The technician grabs one box, does the swap, and the machine is back online in minutes.
That is brilliant. But there is a detail about PE Energy's approach that really grounds this whole discussion in reality. It is how their technical support is described in the source material. They aren't a massive, disconnected call center. The support is provided by people who have actually stood on oil-soaked concrete and fixed injector racks at 2 a.m.
That specific phrase, oil-soaked concrete, carries profound weight in heavy industry.
It really does, because if you have ever been on a job site at 2 a.m. in the freezing cold with a critical piece of machinery dead in the mud, you know exactly what that feels like. The panic, the pressure from management, the physical exhaustion. You do not want to be on the phone with someone calmly reading a troubleshooting script off a monitor.
Not at all.
You want someone who understands the visceral urgency of that moment.
It establishes absolute credibility. It signals to the operations director that their supplier fundamentally understands the reality of fieldwork. A delayed shipment to an office building is an annoyance. A delayed shipment to a remote mining site is a crew of 50 people standing idle, bleeding thousands of dollars an hour.
It's a totally different ballgame.
That specialized, empathetic technical support keeps stockrooms lean, it keeps technicians productive, and ensures the compliance auditors are satisfied because the traceability paperwork is flawless.
Let's look at the actual proof of how this strategy performs in the real world. We have two incredibly impactful case studies from the briefing that demonstrate what happens when you standardize this process. Let's dive into case study 1.
This one is striking.
We have a utilities operator who was absolutely hemorrhaging time and capital. They were losing 12 hours every single month to emergency genset repairs, and every single failure traced back to fuel contamination.
12 hours a month of unplanned downtime for a utility company is an operational nightmare. That kind of unreliability threatens grid stability and triggers massive emergency labor costs.
So they radically changed their approach. They standardized their entire fleet on the Caterpillar 423-8521 program and routed all their procurement through a dedicated wholesale supply partner. The outcome: their emergency callouts plummeted by 80%.
Wow.
And their annual maintenance costs fell by 28%.
A 28% reduction in annual maintenance overhead is massive. That is freed up capital that can be reinvested into grid modernization or new equipment, simply achieved by locking in a proven filtration spec and securing a reliable supply chain.
Let's look at case study 2. We have an oil field service company. They were dealing with a wildly mixed fleet, different engine models, different manufacturers, all spread across multiple demanding locations. They made the strategic decision to consolidate their fuel filters across the board.
Managing a mixed fleet usually results in severe ESCO bloat. You have a warehouse stuffed with hundreds of different filter types, which inevitably leads to technicians grabbing the wrong part in a rush.
Right.
By standardizing their specification and moving to bulk ordering with kitted spares, this oilfield company cut their parts spending by 22%.
Huh.
But more importantly, they saw a massive improvement in their MTBF, their mean time between failures.
So what does this all mean?
It means that standardizing on a premium, proven specification isn't an expense. It is an investment that pays for itself in a matter of months. It eliminates the logistical nightmare of cross-compatibility, drastically reduces the sheer volume of SKUs you have to manage, and permanently stops the bleeding of emergency field repairs.
It fundamentally shifts how you run the business. Let's round this out with some rapid-fire, highly practical buying tips directly from the text for the procurement managers currently in the trenches. These are fantastic, actionable strategies. First up, do not buy on price alone. You must require sample testing and rigorous in-field trials before committing to a massive fleet-wide PO.
Second, interrogate the warranties. Ask for extended warranties, not just on the physical filters, but deeply understand the replacement windows and what kind of secondary damage backing the supplier provides if a part catastrophically fails.
Third, bundle intelligently. This connects directly to the kitting strategy we discuss. The operational mantra should be one PO, one turnaround. Do not just order the bare filter. Ensure the PO includes every necessary gasket, O-ring, and fuel system seal required for the job.
But the final tip requires a fundamental shift in how we think about preventative maintenance. It is the golden rule for mitigating water damage. You must set your reorder points and your maintenance schedules based strictly on runtime hours, never on calendar dates.
Unpack that. Why are runtime hours so much more critical than just saying we swap all filters every 6 months?
Because water ingress is an entirely unpredictable variable. It depends on ambient humidity, temperature swings causing condensation in storage tanks, and the quality of the fuel being delivered by local vendors.
So you really can't guess it.
No. You might have a massive excavator sitting relatively idle for 4 months, or you might run it at maximum continuous load through a brutal soaking wet environment for 3 weeks straight. If you rely on a static calendar date, you are flying blind.
You're just hoping for best.
You might prematurely swap a perfectly clean filter, throwing away money. Or, devastatingly, you might leave a completely saturated filter in an engine simply because the calendar says it isn't time yet, directly causing that catastrophic 5-figure failure.
That makes perfect sense. You have to anchor your maintenance schedule to the actual physical reality of the work the machine is doing, not an arbitrary date on a wall calendar.
If we connect this to the bigger picture, the overarching lesson becomes incredibly clear. A component like the Caterpillar 423-8521 is an exceptional, scientifically proven line of defense against a microscopic threat. But superior technology alone cannot protect a massive operation.
Right, it needs support.
Technology demands a strategy. To genuinely manage uptime, control the vital documentation, and operate efficiently at an industrial scale, you need a dedicated wholesale partner like PE Energy. The ultimate goal isn't learning how to fix broken machinery faster. The goal is to fundamentally shift your operational posture. You want to stop reacting to unpredictable failures and start engineering a supply chain that prevents them from ever occurring in the first place.
And there you have it. We have traveled from microscopic droplets of water imploding inside a precision fuel injector all the way up to the multi-million-dollar supply chain strategies that keep the world's heavy industries moving forward. It is a fantastic reminder that the largest, most powerful operations on Earth rely entirely on the integrity of their smallest components.
And the strategic wisdom of the people sourcing them.
Exactly. I hope you walk away from this deep dive feeling equipped with a powerful new mental model for how industrial reliability actually functions behind the scenes.
It fundamentally changes how you perceive the heavy machinery operating all around us. And it leaves me with a final, somewhat provocative thought for you to ponder. We just discussed how water ingress is wildly unpredictable, and how relying on arbitrary calendar dates for maintenance is a proven recipe for absolute disaster in heavy equipment.
Right.
It makes you wonder, how much of our broader global infrastructure, the vital interconnected systems we rely on every single day, from our power grids to our public transit networks, is currently running on borrowed time, just waiting for an outdated, calendar-based maintenance schedule to finally fail?
That is a thought that will definitely stick with you the next time you see a massive piece of equipment out in the world. Thank you so much for joining us on this deep dive. Stay curious, keep asking the hard questions, and we will catch you next time as we unpack another incredible piece of source material.